Hey, Rudy, how are you doing?
Sir, hello. I'm doing well, thank you. Yourself?
Not bad.
Hi, James.
Hey, hey, Tony. Hey, Andrew.
Hey, James. It looks like changing the name is not persistent.
That's why we're asking earlier.
Yeah.
Oh, yeah.
There's probably something you could do in your settings.
Yeah, I've seen that before. I think if we go to Zoom meeting setting, there's a preferences. I'm not sure if it's done on the website or if it's done here. Let me try to look for that.
Yeah, just for the folks, if you could just put the company name after your name, I think there is a mechanism which I guess we're not sure of, where when you log into these Zoom meetings it'll show, but just to assist everybody so everyone knows.
If you right click on if you click on the three dots above your name, you can actually rename yourself.
Right. Yeah. So if you do that, you can do it on the fly, but I think there's a way you could set it up so when you log in, it always puts your name. So that might be easier. Okay, we'll give everybody a couple minutes to get started. While we're waiting, James, do we have a specific agenda for today?
Yeah, let me share my screen. So, can you see my screen?
Yes.
Yeah, so I think this is the agenda from the last week, so I just copy over here. So do you know if Michael joining today? Michael?
He's on vacation, unfortunately. Yeah. So
yeah, that's what I thought.
yeah. Yep.
So we.
But I would like him at our next meeting to talk about JEDEC compatibility stuff.
Okay. Yeah, so we'll put it on the next meeting. And we also have Jen that's probably scheduled for the next meeting as well. Last time we said 4 weeks from like 2 weeks ago. So
right. Okay.
maybe we can do both at the same time, then we see if we can accommodate that.
Yeah. I have a couple of updates that I want to share, but we'll give everybody else a couple minutes.
Right. Meanwhile, I think people join. I think I just create already. I think this agenda from outside, this objective. I think I probably whenever you get time to run that help people. And then the on the XML side, I check on it. So they're actually the where is that? Hold on. Let me see. Where's my screen? Give me a second. Let me open that. I check that there's a way. Yeah, we can definitely to encrypt the information. So I wrote that provide some information that I think we can encrypt the element in the XML. So I think I kind of like provide that information here. Let's see that document that we started sometimes back. I added here at the end just for references, so people can look into that. And then if they want to do, I think it's a probably good reference there to have, and people can use that. So it is a standard by the W3C for the syntax. So, and generally there are two types of the encryption, symmetric and asymmetric. Pretty much symmetric is like the use the same key, is more like password in a way that you can share that with other people. You can use the same key to encrypt and decrypt on that. For more secure, you can use the public key and private key. So this is more kind of one-on-one. So if there's specific like person or company business you want to share with, you can ask them to share with the private key, and then you can use a private key to encrypt that, and then they can decrypt using the public key then. Right. That is more secure and more one-on-one. This one needs to be like to many people that can use a shared key. So this example, I think I using the JavaScript, not just a library can do that. Like I believe Python, others, Java probably has that similar library as well. I can include that as well. But here there's example that way you can encrypt there, and then after encrypt, then you can see like there's something like more certificate based like S509 509 kind of standard kind of like the encryption information there. So people won't only see this kind of encryption information. Once they decrypt it using this command with the library, and then they can see the actual data from there. So they have to kind of like run the file when encrypt that with the key. And then when people get that, then they can use this key, private key or symmetric key to decrypt it, then they can get the full document with encrypted or decrypted data. So that is there. So I think that's convenient. Yeah, other thing I think it just we talked about last time about adding the components.
Can we just stay on encryption for a minute, maybe finish our thoughts?
Right.
Thank you for looking at it. So this specifies just a kind of schema for encryption, right? Or the algorithms, it's also mentioned in there, or?
Yeah, algorithm, you can look into this one. I think there's a long description. It's a standard
Okay.
for
Yeah.
this WC. Yeah, the syntax you click on the link, and then this document tell you like encrypting, I mean like character, and then it will describe, I think like all right for using a standard algorithm like the AES. So
Right.
I think that's the ISA here to talk about that as well. So I think that's kind of standard kind of format, and you see there's a SHA here. So there's different kind of, I think in that library you can select a format how secure you want, right? So I think 512 is the longest one. Probably it's going to take more secure
Yeah, that
one.
was my next question. Okay, so we can choose what we decide to. I see.
Yes, we can choose what we decide to. I think like so like how secure you want it to be.
Right.
Most secure one say I using the public and private key, and then use the SHA-512. I think that's like longest one. That's probably we can you probably a billion years to people to try to decrypt it.
Do you know if it's also it's for post quantum also? 512?
For which one?
The most SHA 512, is it for post quantum enough as well, or?
I think so. That's an interesting question. The quantum, I'm not sure. Like I probably to get that question, but I think for normal, I think I kind of like superpower, supercomputer, it take like way long time, millions of the year. I think just trying to guess the
Yeah. I don't think any of these are post quantum encryption methods. These are all vulnerable. There's a whole different set of encryption methods for post quantum, and people are working on it. I don't think it's been settled whether what's going to be the way to encrypt post quantum. But James, quick question. So here you're thinking X509, but X509 has two pieces. One is the certificate, and the second one is the certificate authority. How is that going to work?
The certificate, I think like is which if you're using a public and the private key, I think like then that is no real certificate here, right? I mean, it's just pretty much generating your private key and public key, right? Just like the way how you use like the GitHub when you check in the code and things like that.
Yeah, but here's my question, right? There's even in public-private key, there's two parties in this scheme, right? There's the two parties that wish to communicate. Each will have a private key, and each will have a public key. And through the whole algorithm, they can exchange their keys, and then they can start. They can establish a communication, and then they can exchange keys for encryption. If XML is one party, who is going to be the second party?
The second party will be two person. Like I said, I create an XML document I want to share with you. So I'm going to, you're going to give me your private key. I'm going to use your private key, and using my private key will encrypt that data, and that for your private key, only the owner of private key can decrypt on it.
Correct. But in that, it's a communication protocol, right? There's multiple steps, right? And
Yes.
even you're describing it, right? One party gives exchanges keys, then the data gets encrypted, and that exchange is a multi-step process between both parties talking, right? So I'm not understanding how XML on its own can work.
No, I think there's no. I think this is like the recommendation, right? Standard party for XML encryption. That's the way they do anything. There's no built-in something XML. XML is just like a standard format, so it doesn't come with any library building any kind of like the function anything like to do anything. But it does have the syntax, like the element, whatever. I mean, like the schema, and then based on that data, you can do whatever you want to do with your programming. So I think that's why this is kind of add on top of that, right? Which is part of the programming. On top of that, where recommendation here you can do is like using the public key and private key to do that, or you can use asymmetric key, right? So that you can share your key, and then it's only one key you can send together with your document to a person that only have that key that can decrypt it. Is
Okay,
that
I'll take a look at the document. Thank you.
yeah. Any other questions on this?
No. I see Andrea or from HRL. Could you do maybe a quick intro to the team?
Yeah, sorry, it took a minute to unmute. Yes, I'm working on. I don't know if you're familiar with this NGMM effort from DARPA.
Yes, yes.
Oh, yes. So we're, Rudy, his team at Cadence is our consultant, our hopefully partner for the next phases, and we're looking at basically pretty much every single aspect that you're treating here, as far as streamlining ADKs or assembly kits that can be ideally that can facilitate the design process, enable new capabilities, maybe rapid prototyping from the point of view of a couple exemplary architectures. Yeah. So this is very informative. Yeah, thank you so much for
Awesome.
letting us
Welcome.
chat.
So are you with DARPA or?
I am with HRL. Sorry, yeah, DARPA's our
Yeah.
customer.
Yeah.
Yeah.
What is our HRL? I'm sorry.
Oh, sorry. Hughes. It used to be Hughes Research Lab. So we're a subsidiary from GM. And are you familiar with Hughes?
Well, sure. Hughes Aircraft. Yeah.
Yes.
But,
Okay. Yeah. So
yeah.
it got renamed as, I guess,
Right.
or yeah, HRL.
A lot of that going on. I know.
Yeah.
What is it? The guys up in Boston.
Yes.
Who am I thinking of? The missile guys.
Right.
Big R.
Yes.
Yep.
Raytheon. They have a new name as well. Thank you, Rudy. Okay. So yeah. So I guess back to the agenda. I was just going to kind of give James just a kind of a what did you want me to cover? Mission, you said?
Oh yeah, the objective just on top of this.
Sure.
Yeah, so,
okay. Yeah, just to reiterate to existing folks and to communicate to new folks. This is an initiative, and I think it was really initiated through some of the DARPA and GMM projects, but and there were some other government projects that were programs that were looking to develop a set of standardized design kits for advanced packaging. They called them ADKs, but we kind of extended that notion to a broader concept, calling 3DKs and I think the DARPA folks kind of recoined it as 3D HI design kits. But anyhow, we've agreed to collaborate, Cadence and Siemens, in all of these design kits, and we did agree that we would collaborate in developing these through an open forum, and we've chosen OCP to do that, specifically in the CDX group. So, and we have 2 initiatives currently that we're working on, one for ADKs, that's Assembly Design Rules. We meet on alternating Thursdays. So this week is the MDK meeting, Material Design Kits, and then the alternating week is Assembly Design Kits. So we have multiple companies, participating. This is a working group. Like I said, we meet once every 2 weeks for the different topics, either ADK or MDK. And what we're trying to do with the material design kits is to develop a standardized format to define material properties, with the intent of in doing advanced package design, but it's not limited to package design and analysis. But the intent is that we would have a common set of design or a design kit called a material design kit, which would have all the relevant material properties to support whatever analysis is required. So this would be thermal analysis, mechanical stress analysis, electrical signal integrity, RF, you name it. So anything that requires material properties relevant to the design, verification, analysis of advanced packaged products is something that we want to capture in a standardized format. The idea then is for the different analysis tools from respective EDA vendors or custom development scripts is they would draw the information, the material properties that they need in their analysis tools from the standards design kits. So trying to make it a little bit easier for end users to have a common language and define this information in a unified open format. And then the idea is the different tools would then extract this information initially, probably through scripts or an API, but possibly natively support if we do that. So that's kind of the big picture of what we're trying to do here. This is an open group in OCP. The philosophy is open access. What we're doing for these efforts, just to keep some resemblance of control, we do have a JIT depository where we're putting this work. It is open and read access available to the general community, but we're limiting write access, if you will, to participants in these work groups. So and the end goal is so one of the objectives of having it openly available is that it enables immediate access to any end users, so they can start using this to prototype their flows and builds and stuff. This advanced packaging field is moving, it seems like, on a daily basis. Things are changing so rapidly, but the end goal here is, once we get a pretty solid format that we're comfortable with, and we will then seek to have it officially become endorsed by a standards body. We've done something like this with the JEP30 model with JEDEC. So there's, we'll likely probably for the MDKs work with JEDEC to make this an industry standard. Now, as we all know it takes time and a lot of effort and bureaucracy to get these standards published and approved by all the governing bodies. So we do want to do that so it does become a true standard, but we don't want that to gate the ability of people to be able to use this stuff today. And the idea is, even with some of these NGMM programs, which once they start up, the ideas will be kind of discovering new things and modifying, and hopefully we'll get some of those feedbacks back into the working group. So I know Rudy is representing Cadence, and we've got a couple of folks from Siemens. Pratyush and I are both involved in the NGMM DARPA programs. And so that's kind of big picture of what we're trying to do. Similar things on the assembly design role, same philosophy, but different focus. We're looking at assembly design rules, put them in a common format that would describe where you're putting different, actually how the chiplets information, size, dimensions, pin locations, as well as the assembly rules on how those get connected, as well as how things get physically placed in an XYZ coordinate. So if there's interest, anybody here that's not already involved in the ADK meetings, just let David know, and he can add you to the agenda for the bi-weekly ADK meeting. Questions or comments?
Yeah. Thanks, Tony. I think when I get a chance, maybe write a paragraph or two here. I think that might be helpful. I think that's probably last time what we talked about here.
You're recording this?
Yeah, we have that. Maybe you can abstract it from the OCP there.
yeah, it might be easier. Okay.
Here.
So one of the just when we developed the JEP 30 standard, and that's the part model. We limited the focus we created a format which we called CDMXL, and that was specifically targeted at chiplets. And the idea there is we extended the JEP 30 model to include chiplets, and the notion is chiplet design kit. So, and what that is, it's the design views that are required for a chiplet to be used in a system and package design. And with the JEP 30 model, it really does facilitate kind of a marketplace. So we're targeting chiplet developers, and what we have in the JEP 30 is there are an electrical model and a mechanical model that gets into quite a bit of detail of all the relevant information necessary that a package system integrator would need to design and verify a package. And so that information would be put into the JEP 30 library. So essentially, can't think of it as an electronic data book, so that potential users, consumers of those chiplets would know, there's an electrical view that talks about a little bit about the functionality, the ESD coverage, and then the mechanical view will give you the size and the pin locations, whether it's bumped, and a lot of detailed information. So then users could then query this database of chiplet parts out in the market. Now there's no parts today, but the goal is to be able to have a marketplace for these chiplets. And in fact, the charter of the CDX group, Chiplet Design Exchange, is to promote an ecosystem for chiplets. So that is an existing standard that exists today, but what we're doing here is we're building on top of it. Now that we have the chiplets defined in a format, we want to have the ability to add the additional design kits necessary to integrate those chiplets into a package. So in the JEP 30, there is actually a structure for defining material information. It is general purpose, so for the material properties for the specific chiplets is part of the JEP 30 model, but we didn't want to extend all the other components that get into a package, substrates and interposers and fill and all that material, because it's very package specific, design specific. So that's not within the scope of JEP 30. But we do plan on leveraging the structure and the format in JEP 30 to define these material properties. So the good news is we already have a format and we plan to leverage that. And really what we're trying to do with this initiative is to kind of broaden the scope of the types of material, and specifically, the material properties that are necessary to do all the things that are required in the package design and analysis world. So, there's most likely what's in there today is probably not sufficient for the stuff that's required for advanced packaging. So we're really trying to collectively, as a team, come up with essentially a detailed list with all the types of material structures and that are going to be necessary for all the different types of analysis that need to be required. So we do need to kind of articulate the list of what analysis we're going to be using these material properties for, and depending on the frequency, temperature, radiation, whatever, the material properties will likely need different formats. There may be temperature dependencies or all that kind of stuff. So it's not going to be one size fit all. So we're really trying to build a general infrastructure, but also have it flexible enough so if there's new needs, they can be readily adopted with this format as the new needs arise. So to that end, where do we think we are on this list? And I know that ANSYS has done some good work in this area. James, we've had a couple of meetings where we did capture some of this stuff in a list, but I think really that is the goal, to try to come up with this master list of material properties, and then we'll start, once we have that list, we'll start filling out the details of the specific kind of information and the specific structure and how those different material properties need to be, what parameters and such, and then eventually we'll likely have some discussions with some of our JEDEC folks to see what we need to do to get this to potentially either become an extension of JEP 30 or maybe a new separate standard in its entirety. So that's a bit mature, but we want to keep that end in mind when we're doing these things, to try to kind of leverage what we've done for JEP 30, but extend it so it supports all the needs in the advanced packaging world. So I think, James, you're showing the summary of what we have right now.
Yeah, this is summary what we have. And last time we talked about creating the component that you're suggesting, and then also analysis tab. So I start kind of like to readability. I think I put some components there. I think from the list that we have, I kind of particular order that way. Like what we know so far, and then I put some potential, I think, subcategory of that. So like just kind of high level right now. So just and I think I probably this will be a good start, and then like the team here can, I think, like see what you guys are suggesting. This is a good format, and then we can kind of expanding from there. So what do you guys think? Tony, what do you think that works?
Yeah, why don't we just go around the circle? So these are the components that we're proposing to include to have material properties associated with. So
yes.
So when we talk about capacitors, these are going to be integrated, decoupling capacitors, whether it be integrated into a substrate or on a package like component properties. So for the actual physical capacitors, I think that's probably already covered under JEP 30. I would expect.
Do you think that cover the material too, or?
Well, there's two different types of capacitors in my mind, maybe even three. I mean, you're talking about the the components that get put on boards and on a package substrate. So that's one type of capacitor. Then we have capacitors like trench capacitors, and guys, help me out here. What other types of capacitors? So I think there's multiple categories under capacitors.
Yeah. So do you want to distinguish by function or maybe by the way they're built, structure?
Yeah, I think by the way they're built, right? So
Okay.
I think there's general classes, but it's eventually they're going to be used for analysis. So I think we can have a general class for the types of capacitors on how they're built, and then have the properties associated with that.
I see. So what if they're part of like one of the substrates, like one of the, maybe in one of the interposers, they can fabricate capacitors with it. Will it become as a subcategory of, would those passive components come under that SI substrate, or other type of substrate, or would they be its own category separate in the capacitor category?
Well, this is a discussion. So, and
Okay.
in my mind, I think it's not just. Okay, so what do we have? Can you make your font a little bit bigger? Much better, yeah.
Nice.
Trans, is that trans or did you mean trench?
Trans.
Trench, TRENCH. Well, I mean, decoupling cap is more of an application, right? So.
So not included here. We do have a
trench cap. We don't, or things like mem cap. Those are integrated on silicon, so we don't have to.
Yes.
Yeah, that's what
Agreed.
I was going to say. Similar. Would those be in the PDK and less in the, the like for example, the interposer PDK that'd be included there as far as material properties to capture those. Exactly that, MIM or coupling, versus here would be, my thought would be more, SMDs or those type of structures.
Well, the capacitors that are in this certainly in the chiplets, silicon or gas, right? We don't want to just limit it to silicon.
Semiconductors.
That's certainly in the PDK.
Yep.
Now, for silicon interposers, I suppose we could make the argument, there is a technology and a trench capacitor would be included in that MTK, right?
Yeah, I think makes sense. I think there's a silicon that we can use to.
But if it's in the PDK, it's certainly not. That properties associated for that capacitor are not.
You want a database that has them, right? You want a database that centralizes those things. So you probably still need it here.
Yeah. So we need the material properties. So and kind of I suspect for PDKs there's going to be an extracted model that already has an RLC model or for each of those trench caps. But the idea is if you're building a custom structure in the package, then we would need the material properties to do that. So trench, I'm not sure.
But aren't like capacitors, that those are made from multiple materials, yeah? They're kind of components. So
Yeah.
when we talk about material properties, are we treating them like a homogeneous material, even though they're made out of multiple materials? Is that how you treat them?
No, I don't think so. If they're multiple materials, we probably need to have the material properties for all that composite.
Okay, so you'd actually then have to break it down, like onto the foil and the dielectric and.
Yeah, I mean, the components, so they've been around forever, right? Those custom they're commodities, right? For those. So do we really need to address those in MDK, or are the models that are provided with that IP? So that I view is kind of like a chiplet. It's already a component that could be used in a package. It's not a custom component that's being developed as part of the package. So I think those passive physical components that are integrated would be coming from component vendors, and they're presumably providing all the information that would be required for analysis. This is out of my area of expertise, but is that a good assumption that those are already covered?
Well, actually, I think that's a great question, because it almost depends on the manufacturer, on the you mean as far as what information is available on them, right? What kind of.
Right.
Okay, so I think that is part of what needs to be standardized, maybe, as far as it's like almost like a technology file for that component that ideally could be imported into this 3DK environment, and then it'll kind of merge itself with the entire environment or stack.
Okay.
Is that
so? Yeah. So that I don't know, and the guy who would know that is not on the call. He's on vacation. But why don't we take an action for Michael Durkin? The question that I would have is, does JEP 30 support the standardized format for
yes.
not necessarily the materials, but the models that are necessary for
Yes.
It's primarily electrical analysis, but I don't know if mechanics would get into this. Mechanical, so certainly electrical models I think are provided with those components.
And that's a need for the 3D IC, right? You need the mechanics of it as well, so you can kind of make sure that when you put it together, it survives. Sorry.
Yeah. I think for these kind of components, that obviously with electrical, they have electrical kind of, they behave in a certain way. But for thermal, you just kind of treat them as just a homogeneous material. So the capacitor itself has a specific heat and a thermal conductivity, and you wouldn't really model it down to the individual material level. You just and for structural, I know that when we do things like electronics reliability, and you are maybe doing vibration analysis, we just treat those as a weight, as a point mass. We don't try to model within the capacitor. We just say, well, this is a point of a certain mass, because otherwise you get down to very, very detailed, which is very hard to then solve. And there's a lot of workarounds you can do to avoid having to kind of to do that.
Yeah, and I think in the last call, I think it was Applied Materials, they were talking about material properties more for designing a process, so getting down at the molecular level, and that certainly we don't want to get into that level of detail. So I think we need to get Michael to confirm that, but I think we're probably covered for these components, and we can treat them as a black box. I think that
Yeah.
seems like a reasonable assumption. We may want to revisit, see what's in JEP 30 and make sure that, all of our bases are covered.
Yeah, I just included, I think last time, I think we for that, I think it's one of the meeting.
Yeah, so we're going to have a long list of things, and I think we should probably start on the more relevant basic package stuff, and once we start getting comfortable, then we'll start looking at some of these corner cases.
Yeah.
PCB, I'm pretty sure that's already covered in JEP 30.
All right, let me go back.
So material properties for a silicon interposer. I don't think that's represented in, well, Rudy, maybe you can answer this, or anybody else. Does a PDK include all the material information we need for a silicon interposer with respect to the analysis that needs to happen in the advanced packaging world?
PDK itself?
Yeah.
No, but the extraction information that goes with the PDK, yes. So it depends on how you define PDK, but if the PDK is just a tech file, but if it's that combination, yeah, we have everything.
Yeah, you have the extraction files is included with the PDKs.
Correct.
And that would be even for RF type applications.
Yes.
Okay.
Oh wait, that extraction is only for the electrical side of things, right, Rudy?
Right. Right.
So if somebody.
Yeah. So we have, these are the components, and then the other matrix in our table, which is not shown here, is the type of analysis, right? And let's just quickly show what that is. I think that's on your next tab.
Yeah.
So thermal stress, signal, power integrity, power testing, physical. All right, we probably need to revisit this a little bit.
Yeah, just look at this. We need to definitely review this list.
Yeah, but we want to do thermal mechanical stress analysis. We want to do signal integrity analysis, power integrity analysis. I'm not sure what we mean by power.
Predictive.
No, it's a power estimation thing probably.
Yeah.
Most of the things that we're talking about here are passive, right? We're not talking about the chiplets themselves.
That's correct.
So
we don't need
So we probably just lump that in with SIPI.
We should probably just split the SIPI into SI and PI to
separate signal integrity and power integrity analysis. Those are
power is PI.
Often lumped, but very different things.
Yes.
Yeah, spell it out. Let's put signal integrity analysis.
Okay, like this.
Yeah.
Well, I would.
Signal integrity. Yeah. We don't need any separate thing for predictive here.
You're right. I don't think predictable. James, just say signal integrity analysis, and you can put SI in parentheses if you'd like. Just, we're going to have a broad audience, so acronyms can be dangerous when you're dealing with different.
Silicon analysis. What's silicon analysis? They'll say.
I try to put the I as the I, right? So
yes.
They will return the document back to add the acronym table.
Yeah. And I would separate the stress and the thermal because they can be done separately. They're often related, but they're
right.
Yeah, thermal. I'll put the mechanical, right? That encompasses all those things. Right?
So, can we call it mechanical stress and thermal analysis? And mechanical stress, you can't do it without thermal. So I think it's implied. So we could either just say mechanical stress, or should we say thermal mechanical stress?
Warpage, right? Warpage.
Well, and when I talk about mechanical stress, warpage analysis is one type of mechanical stress, but you also have, and that tends to be a little bit more, during the assembly process, and then you also have the thermal cycling, which is more of a reliability. So I like to separate it and call it warpage analysis and thermal cycling. You guys are the experts. Roger, what do you call it? Thermal cycling, mechanical, or warpage? It's not warpage. I call it thermal cycling.
Yeah, it's all
reliability analysis.
Yeah, reliability. Thermal cycling is just basic change in the ambient temperature. In this case, you're talking more about power cycling.
Right. What I meant is that you still have to look at the substrate warpage, right? Like, and all those CTE and all those young modules. Yeah.
Right.
That's what I meant, right? And I think reliability is a different. Yeah, it's a good area, other area too. Yeah.
Right. And we need the
stress.
Material.
You can look at the point of, like, as you said, right, the assembly of the bumps.
Right.
And the localized, stress is more localized, if I understand correctly, right?
Yeah. So we need the material components for each of those slices, if you will, in the stack. But the analysis really is done when you put those together, right? Because they have different thermal coefficients of expansion, and there may be different physical constraints, like stiffeners and stuff. So we need the material properties for each of those things that we're doing for the relevant components in that stack. So the components that go in that stack are defined on the previous tab, but this is what's going to be consuming these material properties, these types of analyses. Okay, so we okay with thermal cycle analysis, everybody?
I think we should just call it thermal analysis, really, because it's part of cycling. Is part of that.
Agreed.
Yeah,
thermal analysis.
Yeah, that's similar.
Well, no, this is so thermal analysis is just looking at the thermal characteristics of your package, right? The thermal cycling is different, because that's really looking at the when you're power cycling, the temperature gradients. There's a mechanical analysis. It's a different tool. You're using a thermal analysis tool to look at the thermal performance of your package, but when you're doing the thermal cycling, you're using those mechanical. You need the thermal, but it's a different type of analysis. I don't think we can lump these.
Do you want to call that reliability parentheses thermal cycle? You know what I mean?
Like what I call it, what I refer to it is thermal cycling reliability analysis.
Okay.
I mean, I think one thing that it can be confusing is because there's the basic physics, and there's only a few basic physics that you can simulate, but then you can start to do different things with those physics. Yep. And you'll often find that it's the basic physics that will determine the material properties, and then you can do, because thermal analysis, it can be static, it can be dynamic,
right?
But basically, you need the same properties, but then you're getting temperatures out of that, and those temperatures you can then feed into your structural analysis to give you the temperatures of the that you need to use the material properties at. It gives you the temperature differentials, which will give you your stress effects, your thermal stress effects, but they all basically boil down to very similar properties, but you can do different things in different combinations. That I put some slides together, which we went through a few meetings ago, which basically boils it down to a few kind of properties, which which are to do with the actual physics. So yeah, what I can do, just if you want to, just I can put another kind of sheet in here which is just for the physics, and just say, well, these are the basic properties you need for different physics. We can then start to combine those together into the type of analysis you do, and I'm hoping that they'll just be subsets or supersets of the properties, and so we're not having to come up with lots of different properties here. When you define it at the physics level, you've actually got your superset of properties that you actually need.
Yep.
Is that somewhere in here you're talking about?
Yeah, that's right. So what I can do, I can turn this into a similar sheet on this spreadsheet we've got, rather than a kind of a set of slides, and then maybe that can feed into the A analysis one.
Yeah. Okay. I think rather than trying to wordsmith this in real time, but in my view, thermal analysis is a separate category, and you can have these subcategories. There you go. Steady state, and but thermal cycling, I view as more as a reliability analysis, right? So warpage analysis, it tends to be, I mean, it is a reliability type analysis, but I think thermal cycling is a little bit different. That's more like a long-term reliability. You know, if you keep operating this, you know, over X number of years with the thermal cycling, eventually you'll get failures. That's a different type of analysis, and it does involve, you know, how the materials degrade over time and statistics and AI type of models. Right. Whereas very, very different than a static thermal analysis or even a dynamic thermal analysis. So these are separate categories. James.
Agreed. Yeah, I mean, I think it was just a name, Tony, but yeah, that's why it's convolving those multiple distributions and getting a. Yep.
Yeah. So we want thermal analysis. That's pretty straightforward. Thermal, not thermal. Thermal, THEMAL. But yeah, I think Andrew, if you could take a crack at, you know, maybe refining this a little bit, and you know, we can even do subcategories, like, you know, under thermal you may have 2 or 3 different types, and then I'm thinking maybe on the columns we can have, you know, half a dozen columns for the different material properties, and maybe put an X for the ones that are applicable.
Yeah.
Tony,
you want to break it down into, let's say, thermomechanical, electromechanical, thermoelectrical, that level, or?
Well, let's let
let's move on, maybe.
Yeah. Let me have a crack at it, like you say, and then we can go through that and see if we agree.
Review it on the next call. So
you
know, we've got a lot of casual thermal mechanical analysis folks here, but well, we do have some experts on the thermal side, but on the mechanical side, I think Andrew can help us out there.
Wait, guys, I think we are approaching the problem. Our final goal is for coming up with a format for that material, right?
That's one of the goals, yes. But we also, again, if we think about the way JEP 30 is structured, you know, there are containers. So the way I would view it is there will be a container for, you know, a substrate for a silicon interposer, and you know, we need to include all the relevant properties in those containers. So with the JEP structure, you know, that is what's the term? James, help me out in XML. The schema. So it's really the schemas this stuff will translate into the schemas. And then the format is how we put the you know, the specific you know, process specific information in that format, and then that'll get put into the schema containers.
So okay, understand, Tony. Here is my point. So I break it up into these things. I see scalar It could be any scalar. It could be conductivity. It could be temperature. It could be anything. I need a way to mention a scalar. I need a way to mention a vector. I need a way to mention XY data. If I maintain these kind of categories, everything else we're talking about here has to fall into those categories. If we know how to mention that in that XML, then we're pretty much solved here. We don't need to find out 1,000 different ways of using the same thing. We just have to define those basic types. Do we have all those things covered? Maybe there is an anisotropic material, which means it has to define about direction, right? So I'm just looking at those categories. That's all I need. Everything else, you can connect the dots. If it's temperature or pressure or whatever, it's a scalar for me. So I'm just
but I think we need to go a bit beyond that, because I think you need to have things like, if you're going to reference a material property, you need to have a name for that property which is common, which is standardized. So I'd agree that we need a format to store the different forms that this data can appear in, but we also need a very standardized way to describe them. I think that's what we're trying to do here, come up with a standardized list.
Right.
So the name to specify that material property. So
yes, I mean things like got Young's modulus, tensile modulus, all those, and that's one of the problems that we have all the time. That people call things different things, and any standard needs to have
thank you.
a standardized way. Yeah.
Yeah, I think that makes sense. And on top of that, I think like for example, CTA and the Young modulus, they use in many places slightly differently, right? So I think specifically kind of structure and standardization can be kind of enforced for that particular way how they use that. Some they use formulas, some they use more like tables style and things like that.
Thank you for the clarification. That I understand now why we need to a little bit more. Okay, thanks.
Right, and then some of these models may need different levels of fidelity, like some may need temperature, pressure, or the orientation, and other types of analysis maybe don't need that. So I think you don't necessarily need all that information for all the type of analysis. So I don't know if we could. I think we want to be able to provide it all, but we don't necessarily want to, restrict or enforce that everyone needs every single type of analysis, right? Because, so you know what I'm saying?
Yeah, makes sense. Yeah, sometimes the unit for measurement slightly different too, right? Some they use because of the level they're using, some using a micro, some maybe at the nano level and things like that.
Right. So if you're just looking for a quick, dirty, if you're doing predictable thermal analysis, we don't need to model fourth order effects of the materials for that, right? Because, we're adding 5 decimal points to something that has, 10%, error bars. So, we need to have full fidelity models, but we also need to have the ability to, when you're doing the analysis, you're going to use a small subset of that model. I don't know if we can come up with a single material model for that, or if we need to have multiple types, low, medium, high fidelity, or just have a superset. And then, some of the stuff is common that has to be there. Maybe others are optional.
Yeah, makes sense. I think this way still makes sense. Either way, I think we have to count what we have, and then from there we can kind of simplify things if we can.
Mm-hmm. Okay. All right. So I think we only have a couple of minutes left. So James, you've got that as an action, right? So.
Yes. So I think here, and then I share the link with everyone. I will put that in the email list as well. This is kind of open to everyone can edit on it. I think I encourage everyone on the call here should go and edit and put a comment or add more things that you see fit, and then we can come back and revisit on this list again.
Okay, is Zane still on the call?
Who you looking for?
Zane, I think he was on earlier, but
I saw him.
I was going to ask an advanced packaging engineer to take a crack at the components. So maybe we can assign Zane an accent. That's what he gets for leaving early.
Yeah, let me put that on the agenda, and then maybe you can follow with him as well.
Yeah.
I think he will be talking next week, right? So probably, yeah, we can also, right?
Yeah. So Andrew is going to take a crack at this analysis table, and we'll ask Zane to kind of review the component tab. And I think we should have, let's put the, I think we should prioritize for the main stuff, and then have a second tier for, the more advanced stuff, and then, stuff that's a little less urgent, kind of keep that at the end. But let's start with the basics and then build on that.
I think that makes sense.
Okay, so Andrea, would you like to be a member of the team, permanent member?
Oh.
She's on mute.
Yes. Enjoy, are you still there?
Okay.
Yeah,
I'll confirm with her. I'll confirm. Ready.
Right. And Mike, I did talk to you about key site. Any progress in finding a key site person to join us?
Yeah, I haven't had luck. Rudy, I don't know if you know anyone.
I do. Let me reach out to him. Yep.
Okay.
Now that I can.
Yeah, I
Yep.
hit a brick wall.
All right, Pratush,
Right.
maybe you could reach out to Scott, see if he's got any contacts.
At Keysight? Okay, yeah.
Yep.
Okay.
Okay.
Okay, thanks everybody.
Yep. Thanks, everyone.
Yeah, bye.
Yeah.
All right, bye.